Hello viewers, in today's class we are going to take up an important topic in three-dimensional geometry, that is equation of a plane passing through three non-collinear points. Now here we have this problem: find the equation of the plane passing through the points r 2 comma 5 comma minus 3, s minus 2 comma minus 3 comma 5, and t 5 comma 3 comma minus 3. So here we'll find the equation of a plane passing through three non-collinear points. Now let us see the meaning of or the importance of non-collinear points. Suppose we have three collinear points, right? Suppose we have three collinear points. Say this is A, this is B, and this is C. Now these 3 points are collinear. Now it is not possible to find the equation of a unique plane, right, which passes through these 3 collinear points. Now if we see, then we conclude that there will be an infinite number of planes passing through three collinear points, right? So that's why it is necessary to say that the 3 points had to be non-collinear, because if the points are collinear, as in this case, then here we have many planes which passes through these 3 collinear points. We can also draw a plane like this, and here we have drawn 3 planes which passes through these 3 collinear points. But here we have to find the equation of a plane which passes through 3 non-collinear points. For example, here we have R, then we have S, and we have T, right? So we have to find the equation of the plane which passes through these 3 non-collinear points. Now let us denote these 3 points by x1, y1, z1. This is x2, y2, z2, and this is x3, y3, z3. Now the equation of the plane which passes through these 3 non-collinear points can be written in the form of a determinant, and the determinant can be written as x minus x1, y minus y1, z minus z1, and here we have x2 minus x1, here we have x3 minus x1, here we have y2 minus y1, and here we have y3 minus y1, and here we have z2 minus z1 and z3 minus z1. So the equation of the plane is given by this determinant, which is equal to 0, right? Now what we will do, we will substitute the values of x1, y1, z1, x2, y2, z2, x3, y3, z3 in this equation, right? So let us see what we get. So we have x minus x1, so x1 is 2, then we have y minus y1, so we have y minus 5, then we have z minus z1, that is z minus 3, right? Then we have x2 minus x1, so we have minus 2, and then we have y2 minus y1, so we have minus 3, minus 5, and z2 minus z1, so we have 5 minus 3, right? And x3 minus x1, so we have 5 minus 2, then we have 3 minus 5, and then we have minus 3 minus 3, right? And this is equal to 0, right? So now this can further be simplified as x minus 2, y minus 5, here we have z plus 3, and this is minus 4, this is minus 8, and this is plus 3. So we have here 5 plus 3 8, here we have 5 minus 2 3, then 3 minus 5 is minus 2, and this is 0, right? So this is equal to 0, right? Now we'll expand this determinant. So we have x minus 2, and then we have minus 8 minus 2 8 0, then we have minus y minus 5, and we have here the determinant minus 4 3, and here we have 8 0, and then we have z plus 3, and the determinant of order 2, here we have minus 4 3 minus 8 minus 2 equal to 0, right? So now we have x minus 2, then we have 0 and plus 16, and minus y minus 5, and here we have 0 minus 24 plus z plus 3, and minus 2 minus 4, that is plus 8, and here we have 24, right? That is equal to 0. Okay, now further simplifying it, we have 16 x minus 2, and here we have plus 24 y minus 5, and here we have 32 z plus 3, right? That is equal to 0. Now dividing throughout by 8, we can further write this equation as this is 8 to the 16. So here we have 2 x minus 2, here we have 3 y minus 5, and here we have 4 z plus 3, that is equal to 0. Now this is 2x and minus 4, then we have 3y, and 3 5s are 15, and here we have 4z plus 12, right, equal to 0. So this is 2x plus 3y plus 4z, and here we have minus 15, and minus 4 is minus 19 plus 12, that is minus 7 is equal to 0. So viewers, this is the Cartesian equation. This is the Cartesian equation of the plane which passes through these three non-collinear points. So here, if we want to convert this Cartesian equation into vector form, we can write it as vector r dot 2i cap plus 3j cap plus 4k cap equal to 7, right? And the normal to the plane is given by n vector, which is 2i cap plus 3j cap plus 4k cap, right? Suppose this is the plane, and then the normal to this plane is given by this vector. So the dr's of the normal vector to this plane are 2, 3 and 4, right? Let us find the equation of a plane passing through three non-collinear points. So here we have the problem, find the equation of the plane passing through the points 1 comma 1 comma 0, 1 comma 2 comma 1, and minus 2 comma 2 comma minus 1, right? So here we have 3 points. Let us denote these points by A, B and C. Here we have 1 comma 1 comma 0, then we have B, that is 1 2 1, and then we have C, minus 2 comma 2 comma minus 1, right? So now we have to find the equation of a plane which passes through these three non-collinear points, right? Now we know that the Cartesian equation of a plane which passes through a point, given point, say x1, y1, z1, is given by ax minus x1 plus b y minus y1 plus c z minus z1 is equal to 0, right? So this is the Cartesian equation of a plane which passes through a given point, right? A given point x1, y1, z1, and the direction ratios of the normal to the plane are given by A, B, and C, right? So since we have used the capital letters here A, B, C, so here we can use the small letters, right? So we can write here A, B, and C. Clear? Okay. So now this plane, right? This plane now passes through 1 comma 1 comma 0. So 1 passes through 1 comma 1 comma 0. So substituting for x1 as 1, y1 as 1, and z1 as 0, this equation becomes a x minus 1 plus b y minus 1 and c z minus 0 equal to 0, right? Now this equation, that is equation number 2, now it passes through this point, right? So 2 passes through 1 comma 2 comma 1. So now substituting for x as 1, y as 2, and z as 1 in equation number 2, so we get a x minus 1, that is 1 minus 1, then we have b, we have 2 minus 1, then we have c, z minus 0, so we have 1 minus 0, right? That is equal to 0. So now this equation becomes this is 0, 1 minus 1 is 0, so here we have 0, here we have b, and here we have c equal to 0, so we have b plus c equal to 0. Now say this equation is equation number 3, right? Now this equation, that is equation number 2, this also passes through this point, right? Because here we are given 3 points, so we have utilized this point, then this point, and now this equation passes through this point. So 2 passes through minus 2 comma 2 comma minus 1. So for x we can write minus 2, for y we can write 2, and for z we can write minus 1. So this equation now becomes a times x minus 1 is minus 2 minus 1 plus b, y minus 1 is 2 minus 1, and then c is minus 1 minus 0 equal to 0. So here we have minus 3, so this is minus 3a, this is plus b, and here we have minus c is equal to 0, right? So this is equation number 4. So viewers, here we have obtained these two equations, right? And now we have to solve these two equations containing a, b, and c, and a, b, c are the direction ratios of the normal vector, right? the normal vector to the plane. Suppose this is the plane, and then this is the normal vector, right? And this normal vector has direction ratios as A, B and C. Clear? Now we have to solve this equation number 3 and equation number 4. So from equation number 3 we can write B is equal to minus C, and let us say B is equal to minus C is equal to some scalar, say lambda, right? So B can be written as lambda and C can be written as minus lambda, right? And substituting the value of B and C in equation number 4, we get minus 3A plus B is lambda, then we have minus C, so this is minus lambda equal to 0, so this is minus 3A plus lambda equal to 0, so this is minus 3A plus 2 lambda equal to 0. Minus 3A is minus 2 lambda, so A is 2 lambda over 3, right? So the value of A is 2 lambda over 3, B is lambda and C is minus lambda, right? Now what we will do, we'll substitute the values of A, B, C which are given in terms of lambda in equation number 2, right? So now this equation number 2 becomes, for A we have 2 lambda over 3 and x minus 1. For B we have lambda, here we have y minus 1. Then we have for C we have minus lambda, and here we have z minus 0 equal to 0, right? Now lambda is not equal to 0 here, so dividing throughout by lambda, we eliminate lambda here, and multiplying throughout by 3, we get 2 times of x minus 1 plus here we have 3 times y minus 1, and here we have minus 3 z equal to 0, right? So lambda is not equal to 0, so eliminating lambda and then multiplying this whole equation by 3, right? So now we have 2x minus 2 plus 3y minus 3 minus 3z equal to 0. So this can further be written as 2x plus 3y minus 3z, and minus 2 and minus 3 is minus 5 equal to 0. This is 2x plus 3y minus 3z equal to 5. So viewers, this is the Cartesian equation of the plane which passes through these three non-collinear points, right? Now if we want to write the equation of this plane in vector form, we can write vector r dot 2y cap plus 3j cap minus 3k cap equal to 5, and the direction ratios of this normal vector, right? The direction ratios of this normal vector are given by 2, 3 and minus 3.